Hello from the Pensacola MESS Hall. Well, actually my living room. Today I'd like to show you a demonstration we call Don't Let It Spread. This model helps visualize the spread of infectious disease in a community, but especially the impact hygienic practices, vaccinations, and social distancing have in slowing its spread. We'd like you to be able to try this at home, so our materials used are simple Cheerios and Fruit Loops. We have set up a 6x6 grid. In my first example, I'll demonstrate the way the game is played. Cheerios denote uninfected individuals in the community, while the red Fruit Loop is someone infected with, for example, influenza. On each day, we will move perpendicularly from the infected individual. Since no one in this community is inoculated or otherwise immune to the virus, it will spread until all have been exposed and infected. Now let's try that with immunity. We've added 6 individuals with immunity either from prior infection or receiving a vaccine. Still infecting left, right, up, and down, the disease will spread until it meets someone immune. Try these 2 scenarios and count how many days it takes to infect the population. Try decreasing and increasing the number of immune people in your population. Okay, let's try a novel scenario. In this one, green Fruit Loops denote individuals vulnerable to serious illness and hospitalization should they contract the disease. You'll note in this scenario, no one is immune. To make matters worse, the virus we are investigating in this scenario is more infectious than the influenza in our previous one. Therefore, we will infect perpendicularly and diagonally. To help us keep track of who is infecting who, we have used different colors for each day. With no measures in place and all susceptible to infection, it took only 3 days to expose and infect all 36 people, including the 12 high-risk individuals. In our final 2 examples, we are introducing a new factor. In this scenario, our community is following CDC guidelines for hygiene, which will enable us to spread only perpendicularly and not diagonally. We also have individuals practicing social distancing in purple. This time we'll use 6 of those, about 16%. After day 7, all of our vulnerable individuals have been infected and none remain. This time, we'll use 12 people practicing social distancing, about 33%. With 33% of the community observing these guidelines, it took 12 days to complete the exposures. After those 12 days, 2 people in the vulnerable category were still unaffected. That's it for our scenarios of Don't Let It Spread. We hope you enjoyed this visualization. This demonstration helps us make comparisons of the impact of immunity, infectivity, and our own measures to prevent disease in our community. Try messing around with the model. Change the proportions of immune and vulnerable people in your population. Increase your sample size with a larger grid, and keep track of the number of people spared or infected in each of your scenarios. Ask yourself, how do different proportions of social distancers and vaccinated individuals impact the rate of an infection in your community? Thanks for joining us.